Hello everybody, welcome to my talk, Draw Database, Event Sorting Fonts for Simple Alliance. So, I don't have much time, so I will try to make it quick. Let's start from a real life story. The real life story is like that. There is one galaxy, and in this galaxy there is a businessman. And he has a dream of building a galaxy-wide pizza delivery. So his domain is like there are 10,000 planets in the galaxy where are living creatures that possibly want to eat pizza. And he wants to deliver them 3 kinds of pizza and 3 sizes of pizza. And he hires one pizza boy with his spaceship. So, and this pizza boy should be able to deliver all those pizza. The spaceship is very quick, and the only problem is that the fuel costs a little bit, so he has to deliver first pizzas to the planet that demands most. Not to the first that people that, or aliens that ordered the pizza, but to those planets where there are most demands for pizza. Okay, so this is the business Galact Pizza. So the businessman gathers the developers. And in this galaxy, he found some Java developers. So the Java developers started to implement service. So what is a Galact Pizza service? Galact Pizza service is something that probably you have something like a place order. So it means the customer can place an order for a planet. Oh, sorry. Let me make it once again. I see some issue with double screen. So we have a place order with size. Okay. Then, after having a place order in interface, I hope you see that, we have something like maybe take orders for best planet. That's the interface for delivery. So you select the best planet and what kind of orders are there. Then you have something maybe for the businessman to see how many orders are in the queue, counting orders, and then you have something like, a debug function for developers to see what kind of orders do we have right now in the system. Okay. So that was this, 4 functions. So what is an order? So an order is something that probably, what has? An order is something that has a planet name. In this galaxy, planet name is enough to find someone who needs a pizza. Planets are small, you know. So, and something like variant and size. That makes us what is an order. So we define this. Yeah. And then we have to define maybe what is a variant of pizza. Of course, we have 3 variants of pizza. The most interesting is Hawaii, then Margarita, and then vegetarian one. So I think everybody should be happy with that. And the resizes of pizza, like those ones, that concludes something that is good enough for everybody. So now let's implement those services. So those guys in this galaxy had no idea that something like databases exist. So they thought, how can we store things that there are orders for pizzas to some planets. So, and they found out quickly that the solution for that, after first writing something with serialization, would be to store that in map. So they used map from string to planet orders. By the way, planet order is simply a list of orders. That's for simplicity, because we want to hide something. Working with a list would be tough. So let's see. This planet orders class look like as follows. It's simply a wrapper for a list where we expose only some selected methods like size, or assign order is basically add. And we also have comparability, so we can select by size which planets have the most orders, or we have a method that mutates this. It simply gives back all the orders and clears this list. So that's the planet orders. So let's implement it further. So we have this hash map of this, and they use concurrent hash map because they want to have the concurrency problem solved. They think so. And they use atomic long for all the total orders that the system contains. So it's like this. So let's go. How can they implement place order? So place order to the planet, to the variant, to the size. Oh, come on, that should be easy. We create an order. So the alien developers created an order like this, because you see that was a simple class order. And they have to assign it to hash map. How do you assign something to hash map? You know? What is a method to assign something to hash map? Smart. Put. Now. Compute if absent, because maybe, okay, put would be a good answer, but we have the problem because if we assign a new order, something already may exist there. So we have maybe to get something first from the map. So that solves compute if absent. It means simply, if there is something exists in this hash map, take it. If not, create it with this recipe, new planet orders. And then we can assign to it. That's the smart way how to assign things to the hash map since Java 8. The Alien developers knew that. You as Java developers probably should learn this also. It really saves you one if and some troubles. And by the way, then at the end, they incremented the orders total counter. So how many orders are in the queue. Now, interesting function, how to select the most demanding planet from this hash map. So for which planet are the most orders? So let's do it. Let's blah, 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 list or take orders from best planet. How do we do it? Let's say orders, so list orders, result would be, we take orders, we take entry set, and from this entry set, we make a stream, and then let's sort this stream. This is a kind of tuples entry set, so we sort it by value, the biggest one on the top. As maybe you remember that those values are comparable because those are those planet orders with lists of orders inside. So we've sorted. Now we find the first one, so the best planet, all of that. Once we found it, we can simply take a value from that, and then we can call the take orders. In case, by the way, it's optional in this moment from find first, so it's monadic approach. The Alien developers knew how to do that. So if no planet was found in this area because there are no orders in the system, then we simply return empty list. And it's and then we decrement the counter of orders because we know how many would be delivered. It's very simple. So those are two most interesting business functions. So let's go further. We have count standing orders. It's how many orders are in the system. Businessman wants to know. So this is very simple. We have this orders total here counter that we increment and decrement here. So it's very simple. So right now the debug function, I don't have much time to explain that, but the developers wanted to take a look at the system every time. So they want to pick what's there inside. So simply they created some supplementary structure. It would be a tuple if they used Java slang, but they didn't. So they made it manually, and they had something like a tuple here. So, by the way, planet summary sample this class. It means planet name and counter how many pizzas. So that they see at the end what's there. Okay, so we have 4 basic functions: place order, take orders, count standing orders, all done on a hash map. So this system works on a hash map. And then simply we have some other, we have a server for that. The Alien developers created a server with Ratpack. By the way, the great way to define servers. So with REST services that answer to those 4 interesting functions. We don't have time to dig into that anymore. And then some things to convert the inputs and outputs to JSON. And some strange Galak pizza wrapper that I will explain later. So at the moment they have system that basically works on a hash map. So let's see how it works. We'll go. I have the system already here in this. This is exactly this code. In the IntelliJ, so I will start it. So the system is started, and now let's see how it works. So this is how it works. Just a moment, we should see something on the screen. But the system performs quite slowly. Do we see something? Or is it? Just a moment. Oh, we see. That's the system. So we can right now order some things. There are, at the right side in the gray, we see the debug. So let's order some pizzas to Earth. So maybe I like Hawaii, of course, the big one. So I will order 2 Hawaiian pizzas. You see, there are 2 pizzas to Earth. And maybe let's order something to Mars. Maybe a margarita. What should they eat on Mars? By the way, so we have 3 pizzas, and then maybe there is a planet Devox somewhere. And Devox will surely eat vegetarian. So if we have I don't know, 4 pizzas to Devox, 5 pizzas, I've ordered so many, so we have totally 8 pizzas in the system. The pizza boy should go to the most demanding planet first. So if I click here, I should see that he delivered to Devox. And you see that the delivery to Devox are done. Okay, so far so good. But this system works on a hash map. It's okay for them, it works. So you may ask what would happen if there is a problem with the power. Like for the moment, I've just forgotten about plugging this thing to my laptop. So you know what would happen normally in the system? This thing. So nothing wrong, because after I connect it and restart the system, yeah, what would really happen is nothing, because the memory nowadays is persistent. So you see, as everything there. But okay, you may say, okay, sorry, that's a stupid trick. Who has a system that runs constantly and you never stop it? Because there are system failures and maybe Windows needs an update and restart. So of course, system needs to be restarted. So let's restart this system, even though the memory is persistent. So I've just stopped the system. If I go here, I should see in a moment some kind of errors. So let me, oh, you see the error. The Angular application is not able to receive the data from the backend anymore. But let's order something to the planet, I don't know, Pluto, and maybe Hawaii, large. It in fact didn't work. So the system is not working, you can trust me. But let's now start it with IntelliJ. So I start it again. And what I see, oh my God, the old orders are there. So, of course, there is nothing for Pluto because the system didn't respond. It wasn't alive at this moment. I can order it right now, but the data is there. Why, you think? Why was hash map persistent? Because, of course, I lied to you. So I skipped one interesting thing called Galak Pizza. So after they implemented this Galak Pizza server on the hash map with 4 methods, they also implemented this Galak Pizza service, these 4 methods, once again, but this time very simple, with using something called persistence controller from project Ironman, and basically each method, like, I don't know, place order, they use it in this way. On the controller, they execute simple lambda, which basically delegates this call further. And nothing more. So you see that every business method, like take orders from best planet, count standing orders, or get planet summary, is some kind of delegation. Either it's execute and query, or query. And what this really does, it, in fact, stores this lambda with all parameters on disk. So I can even show you that. On the disk, there is a folder called pizza, where you see journals and snapshot. In the journals are simply written that place order was called with these parameters. It's simple like that. It's a Java serialization of lambdas. And when the system is restarted, it looks to this folder, and if it sees something in the journal snapshots, then it simply does it once again. So it's simple event sourcing, if you know this term. So, but then comes another reality, what we have to change the system. So the businessman doesn't trust Pizza Boy anymore. He wants to know where all those orders were gone, because if we look at the system, we see what are orders for now, but he doesn't know where were they delivered, I don't know, like yesterday. So we can try to do this. Let's here implement a function. I don't have time to configure something like database or file, so I'll simply print it on the screen. Every time the pizza is delivered, we'll simply put it on the screen. Oh, sorry, that would be looking stupid. Here. Okay, right now we have some system out println. So I will just synchronize it with the IntelliJ. And right now I will stop system in IntelliJ. Sorry for a moment. And you should see this code here. It's right here, this pizza delivered to. And I will do one funny thing. I will delete something called snapshot. Snapshot is the recent state of the system for performance, just to restart it faster. I don't have time to cover this topic, but right now I will start the system. And just take a look at this. You see? Pizza delivered to div devox. Even though this operation was done before, it's right now printed. It means I can restore everything that's happened previously. So it's a very great feature, because maybe at this moment you want to put this information to database because you need it for reporting, data warehouse, whatever. And you can always do that later, even though the system is, I don't know, working like 4 days, and simply like that, you never lose any information because every event that happens to the system is stored. So let's maybe take a look what would happen if you see the data is there, and again, if I deliver something, I don't know, to Earth again, I order something to Earth again, like Hawaii, medium one, so on Earth there should be right now 3 pizzas, and you should see exactly that in the console. It's right now I ordered. If I click here, I should see in the console that exactly there was something delivered to Earth. It works. So this is basically how the system works, even though the guys didn't use any database. They generally implemented the system on a hash map, and it works. It's persistent, and it's quite durable because you can change it, you can restart it. It all works. So you may think that maybe, okay, the performance would be not great because looking for the best planet on this hash map and counting what's the best thing there is quite time-consuming operation. So of course it is. You can use priority queue to do it faster. And in fact, in the longer version of this talk, I consider this scenario, how performant this system could be. And that's the results. I wanted to build something that performs on this laptop more than 10,000 pizzas per second. It means not only orders, but also with delivery. So whole transaction from order to delivery. So I've implemented this in this Java. I would say Java with persistence, simple persistence, Java with hash map, and Java, and classically, probably that you know, Java with Hibernate and MySQL quite tuned. Benchmark and all the code is on a GitHub. You can see that, and that's the results. With this simple approach, everything in memory, with this simple persistence, I achieved something after really easy tuning, 60,000 pizzas per second. It's quite amazing result. The best I achieved with Hibernate plus MySQL, without JPA really to make it as fast as possible, was 1,000 pizzas per second. Just a big difference. And when it comes to rates, I was looking at this count standing orders operations, really counting. That was simple, reading one long. So the result is even more crazy, like 12 millions to 6,000 reads per second. But in reality, in normal application, you would expect that writes are 5. That's the worst result I have ever seen, 200 times faster, and reads are 100 to 1,000 times faster. So reads are basically better. If you use this approach, simple in memory, but persistent. So what I read it, it's at the price of one server or even one notebook, I have a performance like 50 servers. Just take a look at this picture. And without the problems of, I don't know, clustering, connectivity, and all those things, or just at one machine. So it's great. So are there any problems with this approach? So, of course, there is one problem. You need Java developers. And it's really hard to find some Java developers, even here, that probably know about things like compute if absent, priority queue, concurrent skip list, map, copy on write array list, because typical Java developer nowadays only use getters and setters and have no idea about such things. And of course, doing Java concurrency, it's stupid. It's absolutely not the language done for concurrency, so nobody does it. It's scary. And data, one thing, for instance, if you have in a moment to migrate data, you typically are used to write migration script SQL, which is of course great. If you would have to do it in Java, like in those kinds of systems, it would be scary. So nobody likes it. And of course, some people say, this system in one moment it keeps all of this in memory, in a hash map. So it needs huge memory, so it's no-go for most of the system. Oh, come on. 1 terabyte nowadays, you can really order. Even up to 5 terabytes, you can order such servers. So it's really not, the biggest problem is only, I don't really know how JVM performs on 1 terabyte. Till now, I haven't really chance. But up to 100 gigabytes, it's not a problem. And you can count. You can store a lot in 100 gigabytes. And one problem is those systems are too fast. In fact, in this presentation, I used thread sleep to convince you that something is happening, because if you click on order and it immediately happens, everybody thinks that the system is fake. Nothing really works. So I learned that I have to put thread sleep on a lot of places to convince users that something is happening behind. So, okay, advantages of that, of course, testability. That's in fact the biggest advantage I see, because this system is plain Java, doesn't need any machinery. So you remember TDD workshops where they show you how to test 2 plus 2 makes 4. It's so easy. Then you go to your regular job and you see, oh, come on, I can't do it with database and everything. Right now, if you build a system like this, you can do it with persistence, without persistence. In fact, on this GitHub code, you see that I exactly test the system with persistence and without persistence with the same code. This is exactly this code on the screen because I use this common interface. So I can test all this, just the logic and logic with persistence in one place. And it works very, very fast. Performance, of course, that's most biggest selling point, but for me, testability is in fact way more important. Simplicity, you don't have dependencies to some magic stuff like JPA, Hibernate, I don't know, MongoDB, whatever you think of. And you can always, as I showed you, modify the system later. If you, for some reason, need some data to put to, I don't know, reporting somewhere to data warehouse, you can always extend those events, how they process, and store something to database. Okay. And by the way, this, some people, some of you maybe heard, this system is exactly, that's event sourcing. But I call this poor man's event sourcing. It's very simple event sourcing. And you might use this as introduction to the full CQRS event sourcing or even DDD. So, because it's way easier to learn it with that simple approach. So there are alternatives, by the way, because this is a very simple system. The really interesting alternative that's created, who has heard about Legom? Okay, great. So it's a Java framework, microservices, reactive, blah, 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 blah. Who has used Legom? Already, at least, a little bit. Doesn't have to be in production. Okay, great. So, by the way, it's for RESTful microservices, but at the end, it uses CQRS and event sourcing. So, if you work with Legom, you basically work at the end with the same approach. And Akka persistence is, of course, the same thing. So it's also from Lightband. In fact, a session an hour ago was describing this persistence for actor. Also use event sourcing. So it works in the same way that we store events. So some people say, oh, that's just another NoSQL approach where you have everything in memory. But there is a big difference how you design the system. So from my perspective, because in databases, if you classically or NoSQL, SQL, you concentrate on modeling the state. So that's my model entities, what are relations, blah, blah, blah. And that's my state, and that's how I would share it. And this, of course, this is a problem. If sharing state is a performance and error problem, because it's quite error prone. Event sourcing, you concentrate on events. Then you store events, and you replicate events. And the models, you have more models that are optimized for reads. Because of that, it can be incredibly fast. And in this system I shown, my model was in-memory projection of those events that exist. After every system, every restart of the system, I can recreate. Okay, and I call this approach NoDB or DropDB. That's my naming. I use it for more than 10 years. But people call it simply event sourcing. So you may find it under this name. And my summary for you. So who uses JPA? So my message, if you use JPA, you are exactly saying you don't want to mess with database. Great, because you don't need it. Because if you needed database, you would probably use something way better for SQL, like JOQ or iBatis, that you would use the real power of SQL. If you are trying not to touch it, then exactly, you don't need it. You don't need a database. Maybe you need something fast that works fast, and you don't need database-specific features. You just need persistence. And I showed you how to do it with simple Java. And it's what I wanted to show to you. I have some... Of course, you can start quick and small with this Aeroman framework. It's on the GitHub. Code is very small. It's something I would say this framework for storing these things on the disk is something you could do in 2 weekends. Just like this. It's really not big code. And if you are working in a company that's, I know, serious insurance and banking, they will probably not be convinced to use such so simple, because that would be a problem with too big productivity of the developers. So they would probably want to use something like Legom or, I don't know, Akka persistence. So thank you. Are there any questions? Because I have 1 minute, yeah?
In your example, what if I would like delivery expiry date?
Mm-hmm. Okay. So deliver expire, but okay. How would I probably don't understand the question.
The problem is
Oh, great. This problem is solved. In fact, I haven't time to show you on the GitHub, you see it. I store every time with an event is original time stored, and you can access this time. So it's, in fact, there is execute method. You can use the bigger version of that has second parameter, the time of original event creation. So you can use that. So exactly, the same problem is with things like random. You have to make the system totally, reproducible in the same reproducible, and you have to remember about storing the time, but it's done automatically by this framework. That's the problem I know.
Well, this was the very simple case of non-deterministic logic, but in reality you can stack a non-determinism with even Java hash map.
Mm-hmm.
So not iterating in sorted order, just in default order. It may be possible that due to some subtle changes, after restart you have your entries in hash map in different order.
So, okay, I don't have more time. Yes, you have to know how Java works, and you have to take care about this. But by the way, the system doesn't have to be deterministic. It has to do your business logic, and in fact, for some systems, I'm changing this, so after restart they work differently because that's a bug fix. So it's then I restart the system that works differently because using the same events it produces the different value, but that's mostly the thing I want, not the mistake. That's typically how I do bug fixing, because I have all the scenario which leads to the bug stored on the disk. Okay, thank you. If you have more questions, just ask me later. I'm with this shirt, so it's easy to find me.